the I can written down on the screen, but the I can statement says I can prove triangles congruent using HL. And then, again, we've got some pictures of triangles that are congruent. We want you to explain which one of these 5 proves them congruent, and then write the congruent statement. Okay? The reason I'm doing this with you is because there's really only so many different pictures I can draw. Alright, I can change the letters we're all on, but that doesn't change what the picture looks like. And there's only so many facts that you can look for. Okay? And so it's important for you to start to realize that. And if you have all those pictures in your notes and in your homework, and you have them access to them, then when you're taking the test, or if you're taking a quiz, you can look back at seeing how you dealt with those situations, and you should do a lot better. Okay? So in this picture right here, first of all, let's write the congruent statement. We're not going to actually write a proof. We're just going to, let me make sure I didn't, yeah, no. We're not actually going to write the proof. We're just going to state the congruent statement and tell why they're congruent. Okay? Rebecca, you're usually pretty quiet. Can you tell me, the congruent statement, remember, means triangle whatever, congruent to triangle whatever. That's what the congruent statement is. Can you identify in the proper order?
Triangle ABC is congruent to triangle ABC.
Nice. Very good. Triangle, let me actually get a marker, sorry. Triangle ABC congruent to triangle EDC. Now she went from A along the unmarked side to B, and then along the one marked side to C. So if I come over here, A was at the end of the 2 marks, so you go to the end of the 2 marks is E, along the unmarked side, and then along the one marked side. You see what I'm saying? So when they don't give us that statement, that's one way you can use the information they do give you to make sure you put it in the right order. So that's perfect. What's not marked on here that's also true? Brandon? Vertical angles. So angle what? ECB and I'm sorry, ECD, I misspoke.
And then
ACB are congruent because of vertical angles. So now if I just mark those real quick, I don't have to write the statement down, I don't have to say why, they didn't ask for that. But if I just mark them in my picture, it becomes more obvious now. Emily, can you tell me which of these 5 justify why these triangles are congruent? Very good. Side angle side. Okay? The angles between the 2 sides that were given. So you look at, first of all, if you're confused, you look at, you say, well, there's 2 sides are congruent. So come back here, and the only one that has 2 sides and an angle is side angle side. So I go back and I say, is my angle that I'm given between my 2 sides? And hopefully you can understand what I mean by being between. The sides of that angle are the 2 sides that are given. Okay? Good. Tell me real quick with a thumb, are we feeling good about that scenario or bad or somewhere in the middle yet? Come on, everybody reply, please, so I can get where you're at. Okay? Don't feel pressured into it. All right, good. Let's move on. I'll pause while you copy that down. So So looking at this picture, just identifying the congruent statement. Emily, I don't think I've ever picked on you, but can you tell me what triangles are congruent here? AB, triangle ABD congruent to CBD. Good. So starting with the 2 marked angle up to the 1 marked angle along this side, so you do the same over here. C and B and D. So triangle ABD congruent to triangle CBD. Okay. Again, not all 3 facts are marked here, are they? Okay, Megan, you've been gone some days, so you're kind of behind the rest of us, but let me try to see where you're at. And looking at that picture, do you see what is missing, that's what's not marked, that's actually true in that statement? That's awesome, good job. This segment is congruent to itself, and it's in both triangles. So segment BD is congruent to segment BD. Very good. And, what would the reason for that be? How would we explain? Nice. That's reflexive property. Very good. So now, looking at that, Allison, which one of these 5 justify why those triangles are congruent? Angle, angle, side. I have 2 angles and the side not between them. This would be the side that's between them, right? We don't have that. And so if I look at 2 angles and a side, it's either angle, side, angle, or angle, angle, side. Those are the only ones that have 2 angles and a side. And so you are correct. By angle, angle, side. Anybody have questions on that? Okay. Looks pretty easy, doesn't it, when we put it like this? I know it's not really easy, but it's getting better. Another picture here. All right, so again, we're going to identify the triangles are congruent. This is one of those pictures where things are overlapping, right? They aren't just next to each other like they were here or here. They're actually overlapped. One triangle is here, and the other triangle is there. And so if we separated them, it looked like this. Okay? So Carmen, can you identify our congruent statement? Triangle EFC. So let's see, that's EFC, and over here it's ACE. So you went EFC. There you go. CAE. Okay, good. Triangle CAE. Okay, good. Very good. Megan, which fact is not given to us that is true in that picture?
Is it vertical angles?
What? You know, you're right. There are vertical angles here. Quick question for you. Did they tell us the name of that point? So if they don't tell us the name, there's just no way that can be useful to us, right? So yes, they are vertical angles, but they're not useful because we don't know what that point is. So what else is in that picture? Can you see? That's what makes overlapping ones hard sometimes because they're so cluttered. Sorry, I don't want to stress you out. You want me to pass it on to someone else?
Yeah, not for sure.
Okay. Jesse, haven't picked on you. What are you thinking? You see anything that both triangles have? Say again?
C and E.
Okay. If you said segment CE, I would agree. If you're just saying they have point E and point C in common, that's probably not helpful. So, if we would read that as segment EC, then I agree. That's exactly the same in both pictures, isn't it? Now, if I wanted to write that statement, see in this triangle, if I go from E, the one that we started with in our naming, we would go to C. Then over here, if we start with the one we started the naming with, we would go C to E, wouldn't we? Okay, so this is one of those overlaps where they actually reverse the order if you had to write that statement. So if you had to write that, you should write it as segment EC congruent to segment CE. Now again, you know I've said 100 times I'm not going to mark that wrong, but eventually we need you to put that in the right order. So I'm always going to point that out in the right order. So if I marked all this information, we had this angle congruent to this angle. We had this little angle here congruent to this little angle here, and we just said this side is equal to itself. So looking at that, Octavia, if you look at those two triangles now, which one of these, so we have two angles and then there's a side there, which one of these do you think would explain that?
Side angle side.
Well, except they had two angles, right?
Oh, it's angle, angle.
And one side. Say it again.
Angle, angle side.
Okay, look where the side is at.
I don't know.
Well, don't bail on me. You're doing good. But look where the side is at. You see the two angles? Where's the side in relationship to those two angles? Is it between them? Look at the picture here. Is this side between these two angles?
No. Yeah, I don't know.
Yes, it is. Yes, it is. So, whoops there. Wrong one. So, since it is between, the side is between the two angles, we're looking at angle, side, angle. Okay? And so the reason for this is angle, side, angle. All right? Good. You'll get it. Okay, last one. Last one. Okay, here we go. Rebecca, can you tell me the triangles that are congruent? I'm sorry, I can't hear you. Triangle LCA. So you went from this corner up along the 1 mark and then along the 2 mark, right? So that's going to be congruent to what triangle? Nice. ARL. Very good. This corner along the 1 mark and then along the 2 mark. Okay? Had she started any other corner, she wouldn't have gone along the 1 mark then the 2 mark in that order. So that's a good way to identify how to write it properly. Okay? So now that's not the only statement you could have had. Brandon might have said, I want to start with C and gone C-A-L. And then he would have had started with R and gone R-L-A, right? Okay, good. So, what is missing? Go ahead, Jared. What's missing that's not identified in this picture? Segment LA is congruent to itself. That's correct. So, if I was going to write it, would I say segment LA congruent to segment LA, or would I reverse them? Yeah, I'd reverse them. I can tell by looking over here, if I go L to A, then that's the first to the third, so over here, first to third is A to L. Okay? So that'll help me determine the order in which I should write it when I write that statement. Alright, so then, I don't really need to separate these triangles, they're not overlapping, they're just next to each other. Question?
No, I was just gonna make.
Oh, okay, good. What is it?
Side.
Very good. So these triangles are congruent by side, side, side. It's the only one that has all three sides, right? It doesn't matter the order, one side is no different than the other side. Okay? So good. There's 4 that we just practiced. That's the kind of stuff I expect you to know by now. Okay? You may struggle yet to put everything in order, but that's the kind of stuff. So if you still don't have that, then you're just a little bit behind. Not a lot, because I heard a lot of things. I called on a lot of people, and I heard a lot of good things. So I know you're not way behind. You just have to stay positive to yourself, and you have to write down what you do know. And don't bail on the whole problem just because you might be confused on something. Okay? All right, moving along now. Use CPCT to list, I think I said that wrong. Use CPCTC to list each of the other pairs of congruent parts. So does this picture look familiar? What did we say this was congruent by what? Side angle side. And we said this angle was equal to this angle, right? So now using CPCTC, which stands for what? Who can tell me? Go ahead, Jackson.
Corresponding parts
Of
of a triangle,
congruent triangles
of congruent triangles
are congruent. Good. So it's corresponding parts of congruent triangles are congruent. That's what CPCTC stands for. Corresponding parts of congruent triangles are congruent. Okay? Now, using that statement and that fact here, that those are true, what are the other pairs of corresponding parts that are going to be congruent, since I know this was congruent by side angle side? We already said that. So what else has got to be true now? Silas, can you give me one pair? Segment, well, we already had that one.
Oh, yeah.
That's already marked. We want the 3 pairs that are not marked already. Does BC have a mark on it? Okay, so pick one that doesn't have a mark on it, Silas.
AB.
Segment AB is congruent to segment what? Now try to match it up in the right order.
DE. Or ED.
ED, that's correct. A was at the end of the 2 mark, right? And B was at the end of the 1 mark. So if I come over here, end of the 2 mark is E, end of the 1 mark is D. So it's segment ED. Okay? So if I mark that, so I don't come back and do it again, go ahead, Hunter, you've not had a chance to answer today. What's another one that's true?
Angle A is congruent to angle E.
Nice. Angle A congruent to angle E. Have we marked all 3 sides now?
All 3 sides.
Yeah, in the left triangle, do we have a mark on all 3 sides? Yeah, do we have a mark on all 3 sides in the right triangle?
Yep.
Yeah, so the only thing left is an angle. What is it, Emily?
I was gonna ask.
Oh, I forgot to mark it. A and E. What's your question, Emily?
Do you have ending?
No.
I just asked when on the
I don't have a Band-Aid. Sorry. Yeah, you can go to the office and get a Band-Aid. So who can answer the last question? Yeah.
Angle B is congruent to
Angle B is congruent to angle D.
angle D.
three facts that were not already stated, and those are all true statements because of this. So if this was a proof, and they ask you to prove that angle B is, angle B is congruent to angle D, you would have proved the triangle is congruent by this, and then you would have made this statement. And your reason for that would have been CPCTC. Okay? Alright? You've already got this picture drawn. We've already proven it was congruent by what? Angle, side. And reflexive told us what, Jeffrey? Can you speak so I can hear you? BD, yeah. BD was equal to itself, right? Okay, that was reflexive. All right, good. Now, we have our three marked there that we use to prove it congruent by angle, side. So now, what other three facts do we have? Go ahead. If you think you know one, go ahead and tell me. We'll go you 1, 2, and 3.
Segment AB is congruent to segment CB.
Okay, good. Segment AB congruent to segment CB. All right, good. He went from 2 marks on this angle up to 1 mark, and so over here he went 2 marks on this angle up to 1 mark right there. All right, good. Sure. Segment AD and segment CD. Again, 2 marks to no mark, and then 2 marks to no mark. So segment AD congruent to segment CD. And then the last one has not been marked yet. Brandon. Oh no, it's
Yeah,
Megan.
she took one that I had.
Oh, you don't see the last one?
Is it the angle? Is it ADB?
Nice, very good. We can't just call it D, can we? Because there's too much going on there. So you did well. Angle ADB congruent to angle.
CDB?
Nice. CDB. Very good. Good job, guys. Good job. The third one. Again, you already have this picture drawn. We had unwrapped it. I should say unlapped it. It was overlapped and we unlapped it. Probably that term wouldn't fly in language arts class, but math teachers aren't known for their language arts skills, so we'll go along with it. So, what piece was the third fact? Brandon, do you remember what piece we had marked?
EC.
EC and CE, right? And so that was equal to itself. And so this is congruent by what?
Angle, side angle.
Nice. And so what are our 3 facts this time? What 3 people? Titus wants to give one. Who else? Dalton? You want to give one? Magnolia, I haven't picked on you yet today. I'll let you do the first one, Magnolia.
I don't know how to do it.
Can you identify just one thing in the triangle that's kind of like on the left here? Let me do this. We had already done this, so I'll make one yellow and one green. Do we have any Packer fans in here? Sorry, Silas. I don't want to gloat at your misery because I hate that when people do that to me, but I sure enjoyed the Lions win yesterday. If you give me 1,000 to 1 odds, I wouldn't have put $1 on the Lions.
Yeah.
I didn't waste any time watching it. I was out for my hunting stand. But anyway, so Magnolia, you got some help now? So we have the green triangle and the yellow triangle. You name one thing that's not marked yet in the yellow triangle.
Would it be segment AE is congruent to segment
AE and
FC?
FC, that works. So this segment AE is congruent to this segment FC. Silas, can you give, let's see, AE, I'll just put 3 marks on them. And they'll be overlapping, because they overlap. Silas, you want to give one now?
I would say segment FE is congruent to segment CA.
Okay, you went FC up here where there's no marks down to where there's an angle mark.
Yeah.
So over here you should go
Yeah, angle. Segment
A, no
AC.
mark, down to 1 here, right?
Yep.
So segment FE congruent to segment AC. I'm not sure you said it right the first time, but we got it right now. Okay? You had the right sides though, and that's the biggest thing. I'm not going to mark it wrong. It might be a little contradictory. I hope you understand where I'm coming from when I'm kind of nitpicking at how we say it now, and then I follow it up with, I'm not going to mark that wrong. It's like I'm saying it's important, but it's not important. It really is important. I just think the bigger picture for points is more important. Okay? Jesse, you need to stay with us. What is the last fact? Who was the third person? I thought we had identified 3 already. Dalton. He was hoping I forgot. There's one thing yet that's not marked. Is it an angle or a side, Dalton?
Angle.
Good. So you've identified that. Which ones?
F is congruent to angle A.
Nice. Angle F congruent to angle A. Good job. This one is congruent to this. Okay? Those 3 facts we know because of CPCTC. Then the last one right here. We said these triangles were congruent by side, 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 because we had reflexive here, didn't we? So my 3 facts over here are all going to be what? Angles. Brad, you almost got through it today without me picking on you. Can you name one of the angles? What if you can, why don't you name the hardest one to name?
Which one's that?
I don't know. That's up to you.
Angle C is congruent to angle R.
Okay, that's not the hardest one to name. Good job. Angle C congruent to angle R. Is there anybody I've not got an answer yet? Amber. It's been driving you nuts, isn't it? You like the answer. Good job.
Angle LAR is congruent to angle ALC.
Sorry, I forgot to mark this. And then you said LAR congruent to angle
ALC.
ALC. Very good. Angle LAR congruent to angle ARC.
No, AL. Yeah, ALC.
ALC. Nice. When I start that again. LAR and so ALC. Okay, good. Good job. Anybody else I've not let answer yet today? Really? I picked on every single person in here? I picked on Carmen. Yeah? I think Katie's answered, haven't you? I got Rebecca.
Yeah,
I got both Rebeccas. Katie, did you answer yet?
One today?
Yeah. Do you want to answer the last one?
Would it be angle ALAC and angle ALR? LAC, that's this angle. So angle LAC is congruent to angle, let's see,
LA, so A, what'd you say?
Angle ALR.
Nice. A L R. So that's this thing. Okay? Very good. Very good. Nice job, guys. As a group, you guys are 100% today. Emily, you have a question? No. Okay.
He's like,
A for the day, huh?
Use the homework, right?
All right. Today, today we're going to talk about, or we're not going to talk about any much more specific. So if my given, this is our last example. We're going to write a proof using HL. So you can see that there's not a lot of new stuff here. All right? HL stands for hypotenuse leg. And if you look up the rule in the book, it's going to say something like this. If the hypotenuse and leg of one triangle are congruent to a hypotenuse and leg of a second triangle, then the triangles are congruent. Okay? That's what it's going to say. And so given segment BD perpendicular segment AC and segment AB congruent to segment CB. Okay? And we want to prove triangle ABD congruent to triangle CBD. Okay? So, who can give me the first step to writing this proof? What is it? The given, which says segment BD perpendicular to segment AC and segment AB congruent to segment CB, and the reason? Given. Okay? So how many direct facts were in the given? One. Right? Just this one is a direct fact. It led directly to us knowing that's equal to this. The other one just said perpendicular. It says that this is perpendicular. Okay? So the question is, what does perpendicular lead us to write? What do we know if two segments are perpendicular? What's that mean? What's that? Actually, it means they're right angles. That's correct. So we're going to say angle ADB and angle CDB are right angles. Okay? How did I know they were right angles? Definition of perpendicular. That's right. So definition of perpendicular. definition of perpendicular. Now, if those two angles are perpendicular, well, then what's that, or I'm sorry, if they're both right angles, what's special about that?
They're congruent.
They're congruent. So we're going to say angle ADB is congruent to angle CDB. Oh, I'm sorry. That's true, but that's not the route we wanted to take on this problem, okay? This is a true statement, what we were about to write, but I'm sorry I got distracted on where I was headed. If these angles are both right angles, what does that mean about my triangles? They're right triangles, okay? So we're going to say triangle ADB and triangle CDB are right triangles, and that's the definition of right triangles. The definition of a right triangle simply says if it has a right angle, it's a right triangle. Right? Okay, so I know that, can I slide this up? I know that this is a right triangle now, and I know that this is a right triangle, and I know these sides are equal. Well, what is the name of the side if it's a right triangle? It's called the what?
Hypotenuse.
The hypotenuse. So to use HL, I need hypotenuse, I need a leg, and I need to know that it's a right triangle. I need those three facts. So if they don't tell me it's a right triangle, I have to tell them it's a right triangle. That's why this step is important. Okay? So what other fact is missing here? Whoa, get back there. What other fact is missing here that we need?
The leg.
A leg. Okay, there's a leg missing. Do we see what that leg is? Amber?
Segment BD is congruent to segment BD.
That's correct. It's congruent to itself, isn't it? So step 4 is going to say segment BD congruent to segment BD by reflexive property. Okay? Yeah.
What if you put segment BD is congruent to segment BD before?
Oh, that's fine. Yep. That's fine. She's asking, if you couldn't hear that at home, she's asking, what if I put this step one of these other places? And it's fine. You can put that step wherever you want as long as it's before this last step, which says triangle ADB is congruent to triangle CDB by HL. So to be HL, we need three things. We need the hypotenuse. Okay? We need a leg. And we need to know the fact that they are right triangles. Okay, we need those three things to be able to use HL. Now the reality is, after what we learned last week, if these sides are equal, what's that tell us about the angles opposite them? They're also congruent. We also had a theorem said the bisector is the angle is the perpendicular bisector of the base. And so if this is a perpendicular bisector of the, well, I guess I don't know necessarily that's perpendicular.
I think it has to be because it's.
There's a lot of facts we can get though that because it's an isosceles triangle. What were you saying, Jackson?
I think it has to be because those other two sides are equal. A, B, and C.
Yeah, I'd have to give that some thought. I don't want to say something that would be wrong. I don't know if we could go the other way with that. But anyway, this is one way to write that proof using, and it's the basic way you'd have to do it to use HL, okay? Now, we don't have, I'm not gonna give you an assignment, but I want you to look at one problem for me, and you can do it with your group. Number 11 has a flow proof started for you. You can ignore that or use that to help you guide you. I want you to write a 2-column proof for number 11. Okay, so I want you to use the time you have left here, about 6 minutes. You and your group do number 11. Okay, what's that? Lesson 4-6, it's page 220.
Is it still notes or?
Well, there's not going to be a lot of homework on this lesson, so do that one. You put it with your notes, or you could put homework. Tomorrow I will give you a few more problems to practice. We'll do some things together again. So for today, the only thing I want you to do is number 11.